All right, let's start with this example where we have x plus 2 quantity squared over 9 minus y minus 1 quantity squared over 16 equals 1. Again, the center, same way we did with an ellipse, is at negative 2, 1. A is going to be equal to the square root of that, so that's 3. B is going to be the square root of that, which is 4. And then I told you we had this relationship that a squared plus b squared is equal to c squared. So 3 squared plus 4 squared, hopefully you remember that from a 3, 4, 5 triangle, would cause c to be equal to 5. Okay? So if I go ahead and graph in my centers here at negative 2, 1, because the x is first, it's squared and it's over the positive value, I can tell you that this hyperbola, just the general idea is it's going to be opening left and right like that. Okay? Now to get that first point, so these are what the vertices are, I need to go a units from the center. Well, if a is 3, I'm going to go over 3, 1, 2, 3, and I'm going to go over 3 in this direction, 1, 2, 3. So I have vertices then at negative 5, 1 and at 1, 1. Okay, so I was adding and subtracting a to the x value there. Okay, the foci, just like before, the foci were always inside the parabola. Foci were always inside the ellipse. The foci are always going to be inside the hyperbola. So I would go 5 units from the center. So if I just continued this out a little bit, I'd go here to negative 7, 1 and 1, 2, 3, 4, 5 to 3, 1. Okay. Now, drawing it tends to be a challenge because I say, how wide? Should I make it really tall? Should I make it narrow? How do I know something like that? That's where asymptotes come into play. Okay, I'm going to move that over so we see it a little bit better. And this is where our two different axes come in. The transverse axis is going to be where our vertices are on. But then we have this conjugate axis. And the conjugate axis and the transverse axis together help us to make this little box that help us to see what our asymptotes are. So I always think if I went over 3 here and 3 that way, I need to go up 4 and down 4. 1, 2, 3, 4. Now, there aren't points. It's not like those are going to be vertices like they were in an ellipse. But we make this kind of box that goes through our conjugate axis and our transverse axis. So I'm going to erase those so we just see the box. And usually I leave the box in when I'm going to graph this. And then I'm going to have asymptotes that go through the center and through the corners of that box. Okay? So the asymptotes, if I put them in point slope form, will always be y minus the y coordinate, so y minus 1 equals the slope, and then x minus the x coordinate, which in this case, since it's negative 2, would give me x plus 2. So those parts come directly from here. What's my slope? In this case, because I'm opening left and right, my slope is b over a. So I would have 4 over 3. I also am going, so that's for this one's rise over run. I'm also going down 4 and over 3 to do that line. So it's plus or minus 4/3 times x plus 2. And then if I was going to sketch the actual hyperbola, it would go right up to those asymptotes but not cross them. And so that's what the asymptote would look like. So again, I have some things that we've talked about, that 2a is what's called the transverse axis. 2b is called the conjugate axis. So very similar to major and minor, but transverse in this case is smaller than the conjugate. But that's everything that you need to see from that example.